Hey guys, today I'm going to do notes on something called biogeochemical cycles. If you need to find more resources on this, you can find it in your textbook in chapter 4.3 called Cycles of Matter. So processes that cycle matter. We've already talked about processes that cycle energy, or how energy flows through an ecosystem. Now we're going to look at how matter, so things that are atoms or minerals, molecules, those type of things that can go through a ecosystem and that are cycled through it. So cycling, we mean that it will basically always stay in there and will just maybe change forms. So there are physical and chemical ones. Water cycle is one of those. Human activities can cause different things to cycle through an environment, and we'll look at how humans can impact that. Geological processes, so things like phosphorus, we'll look at the phosphorus cycle. So it's kind of part of the rock, like one of the rock cycles. And then biological processes, so things, how living things can cycle matter as well. Like the nitrogen cycle is a big one here too. So this big word, biogeochemical cycles. So let's break this down. Bio means life. You are in biology class, the study of life. So bio. Geo pertains to earth, like the study of the earth is the study of geology. And then chemical involves chemicals, so involves any atoms or molecules or elements. And then cycle is an item that is repeatedly moved in and out of a system or back and forth. So a cycle, like the water cycle. Water moves around and around and around in one place or in our entire world. So this is the water cycle, something that you guys have learned about for a while, since you were probably little babies in elementary school. So the water cycle, that has to do with water. There's different forms that water can take. It can take a liquid form in which, it would be in rain or in the ocean. It can take a gaseous form, or gaseous, however you'd like to say that, in which it would be like fog or a cloud. And it can also take the form of a solid form, so in the form of like ice, which we don't really have that up here in my picture. But the water cycle, one thing to know is that, it doesn't just, water isn't just, comes down from the clouds and then goes into, with precipitation and then lands up in a tree or lands up in the ocean and stays there. Now, it might come down and it go into the ocean and stay there for 1,000 years. Maybe one water molecule might be up in this cloud for 10 days, and then it decides to rain down, or not decides to, but precipitation happens and the cloud gets too heavy, all that water starts to condense, and you have precipitation down. And then the water might run off into a river or an ocean, and it could stay there for 1,000 years. And then that one water molecule might one day find its way towards the top and evaporate. Water can also find its way into living things like plants and animals. All living things need water. So plants and animals are a biological part of this water cycle. And if plants get them, then they're going to do something called transpiration, where you have a liquid form inside of our plants, and then they are going to transpire. We'll learn more about that in the next unit. And that can form clouds as well. So the water cycle, make sure you know all parts of this. All parts of this water cycle you need to know, and these will be in your terms to know at the end of the notes. So you can do them there as well, but let me go over them very quickly here. So condensation would be when water turns from an air or a gaseous form to, so let me say gas. It's when it goes from a gas to a liquid. That's when it goes from a gas to a liquid. This happens in the clouds, usually. Precipitation is rain. Okay, so when your clouds get too heavy and there's a lot of condensation happening, and then all that water falls down. So precipitation is rain. Evaporation is when we go from a liquid to a gas. Okay, and this is what also forms clouds. So we can say that condensation happens in clouds and evaporation is what forms clouds. Transpiration, this is what happens in plants. So in plants, when they release water vapor, so this is another way that it can go from a liquid to a gas, but the key word is plants. It happens inside of a plant or an organism or animals. So plants and animals do that. And then runoff, that is when rain or water runs over land. And usually it carries materials with it. Some forms of pollution can happen in what we call runoff pollution. So as it rains on on your yard, if your yard has different elevation, like for example, my yard, it has part of my driveway kind of rolls down into the house. And so when it rains, there's runoff down my driveway, and there's always a big puddle at the bottom of the driveway right in front of my house and where I park my car. So if it rains, I have to make sure to not step in those puddles when I'm trying to get into my car. So that's runoff. So again, we just went over all of the terms that you saw in here except for collection, but y'all know what that is. So make sure you know those. Now I'd like for you guys to pause the video for a second and answer these two questions in your notes. So water consumption, how do you use water in your daily life? And what are some ways that you can conserve water? Because one of the really cool things about the water cycle, and with all of the cycles that we talk about today, all of the water that's on Earth right now is the same amount of water that was here when Earth first formed, or when water started to condense billions of years ago. So when dinosaurs drank water millions and millions of years ago, you could be drinking today the same water that dinosaurs drank forever ago, or that Abraham Lincoln drank forever ago. You could be drinking like tiny little molecules of water that might have at one time been inside another human, thousands of years ago. I think that's pretty cool. So all the water on Earth is reused and recycled. That's why it's called the water cycle. It is reused and goes in this, goes through all these different steps forever until the Earth blows up. So make sure you answer these two questions. Pause the video now. Moving on, we have the carbon cycle. So this is how carbon, the atom carbon, is cycled through the environment. Now, usually it's cycled in the form of CO2, carbon dioxide, which you've probably heard before. Carbon dioxide is what animals and organisms, plants as well, give off. So when we're talking, when we're breathing, when we breathe in oxygen, and we exhale carbon dioxide. We'll go more into that next unit, or maybe in 2 units, when we talk about photosynthesis and cellular respiration. But right now, you just need to know that the carbon cycle has to deal with this carbon atom, C, and how it cycles through our environment. So there's different things that create carbon dioxide, Animals create it by exhaling. We breathe in CO2, or we breathe in oxygen, and we give off carbon dioxide. So animals can contribute to carbon dioxide in the air. Plants help to absorb that. So that's really why it's one of the best ways to kind of help with global warming or to help with greenhouse gases is to plant a tree. It's because trees and plants, they absorb that. They use carbon dioxide. They fix it in their leaves and in their cells, and they actually produce oxygen. So it's a really good thing that to have plants and to have as many plants as we can in this world, because they take up carbon dioxide and they emit oxygen, which is what we breathe. We need oxygen to survive. Other things that create CO2 are decomposing things. So fall time, there's a lot of plants that are shedding their leaves. Those leaves decompose and they're giving off a lot of CO2, carbon dioxide. So remember, you know that is called carbon dioxide. Di meaning two. There's two oxygen atoms, two oxygen, and one carbon atom. If you take chemistry next year, you go into more detail with that, but this is really all you need to know as far as naming elements are concerned in biology. So animals eat plants which contain carbon, and then we give it off. We also poop. You might have seen the little poop right there. Animals and humans, all organisms poop, and that also gives off CO2 into the air. And then humans have a big part in carbon dioxide. We can take dead things, we can take plants, we can take decomposing matter, we can take oil, which is just really, really, really old decomposing matter from hundreds of thousands of years ago. And we can burn that. So when you are burning, a car that is burning, you might have heard the word fossil fuel. So burning fossil fuels, that gives off CO2 as well. So everything in this picture gives off or creates carbon dioxide except for plants. Plants will absorb it and create oxygen. This can become a problem because if you have too much carbon dioxide can get trapped in the Earth's atmosphere, right? It can't really leave the planet, and so it can get trapped here. Carbon dioxide helps to trap sunlight, so sunlight that hits the Earth is reflected and becomes heat. Carbon dioxide and other gases in the atmosphere trap heat, keeping the Earth warm. So if you have too much CO2, too much carbon dioxide in your atmosphere, then more and more of this Earth more and more of the sunlight that comes in will stay here and won't bounce off and will keep warming the Earth. So a greenhouse is something that stays very warm, so and traps the sun's light. Mostly you keep plants in there. We have a greenhouse here at the school. So that's good for if you're a plant, but it's not so good if you're a human living on the Earth and you can't escape. So if we're creating too much carbon dioxide, you can warm the Earth up too much, and then that leads to other things. We'll get more into that later this week when we talk about climate change and some of the other effects of too many greenhouse gases. And remember, this is all because human impact. So humans, if we're burning too much fossil fuel, if we have too many animals like farming cows and chickens, things that poop a lot, okay? If you have too many of those things, you can have too much carbon dioxide in the atmosphere, more than natural. Like when we're burning coal or we're burning other fossil fuels, you're putting more carbon dioxide in the air than is natural, or we're putting too much in too fast, and so then the sunlight is getting caught in the Earth's atmosphere and warming it up faster than humans can kind of keep up with. All right, and now we're going to switch to the nitrogen cycle. So this is the nitrogen cycle. And again, we're cycling nitrogen, and you can probably see already that this is a lot. There's a lot going on here, but I'm going to show you a few things to focus on. So nitrogen is very important for plants. So it's very important for plants right here. And it's important for animals. Okay, we need to eat nitrogen, and plants need nitrogen to grow. So when they are growing, they are going to get nitrogen from the soil. One of the most important places to get nitrogen from the soil, or ways to get nitrogen from the soil, is from this little guy here, bacteria. So bacteria, and again right here. Bacteria, they're able to take nitrogen that's in the air, right here. There's tons of nitrogen in the air. There's more nitrogen in the air than oxygen. So there's more nitrogen in the air than oxygen. It's not really that big of a deal because we can't use it if it's in the air. It's not like that. It's not like oxygen in that when we breathe in nitrogen, it's not really doing anything. We have to get nitrogen by eating it. And where do we get nitrogen from eating it? We got to eat plants, or an organism has to eat plants, and then we eat that organism. So, but how do we get it from the air? We can't, but bacteria can. So there are these bacteria that it calls, it says that they are nitrogen fixation. Basically, they take the nitrogen in the air that we can't use, and they fix it. So through this crazy process right here, don't worry about it. But they take this form of nitrogen, they change it to a form that can be used, and then look here, our plants can now use it. So nitrogen fixing bacteria. Bacteria are our friends because they take nitrogen, they change it through all these weird, crazy processes. You don't have to worry about the crazy processes. You just need to know that bacteria takes nitrogen from the air, and they fix it so that plants can use it, and then we can use it. And then there's also other bacteria that go through the reverse process. They are called denitrification, and they take whatever form of nitrogen that isn't used up here, and then they spit it back out into the environment. So one of the most important things to remember from this, cycle is that bacteria turn nitrogen in the air into a usable form that we can use and plants can use. Okay, this is the very last cycle that you need to know. This is called the phosphorus cycle, and it is so much easier than any of the other cycles we've talked about. Phosphorus cycle. So phosphorus is an atom. It is an atom that is mainly found in living things need, but it's found in rocks and sediment and deposits. So at the very beginning, the picture that I showed, this picture right here, a geological process, and I was talking about the rock cycle. This is one of those. This is the phosphorus cycle. So phosphorus is very important. It's important for living things. It's important for plants and animals. We need phosphorus. So all living things need it. So plants and animals and bacteria, fungi, any kind of living thing needs phosphorus. And the only way to get that is, well, ideally, because, you know, we don't get it from just eating rocks. We get it from living things, from eating other things. So rocks, deposits, and sediments, basically they will dissolve over time with water. So water will erode, away. That means kind of chip away at rocks, and will create usable phosphorus that plants can then use and animals can use. This is another picture of the same cycle, of the phosphorus cycle. So let me write that. Let me move my face down here. This is the phosphorus cycle. That's how you spell that, phosphorus. I think I spelled it right. Yep, phosphorus. No second O. So just phosphorus. So these are other ways to show the phosphorus atom moving around on the Earth. So you can see this blue arrow shows biological, so living things. Using phosphorus, we can use it from the soil. If it's already in the soil, plants can get it out. Animals will eat it. We eat other animals, so that's one way that you can get it. There's dissolved phosphorus in the ocean or in marine areas where, organisms that are over here living in the water, they can get it just from the water because it's already dissolved in the water. Humans can use it. Big part of fertilizers is phosphorus, so we can kind of isolate it and use it as well in plants and things like that, like not a nuclear plant, but fertilizer plants, basically big companies that will make a lot of fertilizer or make phosphorus. And then the main way that we talked about also is geological processes. So you have phosphate, the phosphate atom or the phosphorus atom in a rock, and over time it gets broken up by water and different things, and it can then dissolve into water or onto land, and that's another way. So phosphorus cycle, make sure you see these arrows, they go back and forth. Okay, they go back and forth. So living things can grab phosphorus and then they might die and it might go back into the rock sediment or deposits. These things can erode away and then go into water, or they can start to deposit and come back. And then this way too, living things can get phosphorus from the water that they use, and then it can also go back into that way. So different ways, that's why it's called a cycle. There's many different ways that it can go. So just to review very quickly, these are the 4 cycles that we went over today. Make sure that you know what biogeochemical cycle means. Make sure that you know bio means something living, geo means something from the earth, and then chemical. Cycles, this is how we cycle matter, or how matter is reused in the environment. We had the water cycle. So make sure that you know all of those different terms that we talked about: precipitation, condensation, transpiration, evaporation, all of those. So look at your terms to know for that. The carbon cycle, make sure you know that all living things create CO2, and plants are the only thing, plants absorb CO2. That's why they're so important for the environment, because carbon is also a greenhouse gas. So make sure you know that we talked about greenhouse gases for this too, greenhouse gases. The nitrogen cycle, this was the really crazy one. This one is very important for living things. Make sure that you know that bacteria were the very important guys. Bacteria are in the soil, and they are what turn nitrogen in the air into a usable, I think I spelled that wrong, usable, I can't spell today, a usable form. So bacteria are the important guys that turn nitrogen in the air to the usable form. And then the last thing is we have the phosphorus cycle. This one was pretty simple, mainly just went from water to rocks to living things. You move my face up up here. Water to rocks to living things. And they can cycle back and forth, so it kind of looked like this. Phosphorus was with the phosphorus atom, nitrogen was with nitrogen, bacteria were the important guys, carbon. All living things create carbon dioxide. Plants are the only thing that can absorb it. That is a greenhouse gas. That's why it's so important. And then the water cycle. All those different terms, make sure you understand all of those.